Hello, so I'm going to start up. This is the second video over the factoring summary. So let's go ahead and continue. Oops, I hit the wrong button. I apologize. Hang on a minute. What a mess. Okay, so it's still the same thing. I say factor, you say greatest common factor, and there isn't one between the two terms, but you still ask. And then you say, well, what is it? It's a binomial. If it's a binomial, is it maybe a difference of squares? And by difference, I mean this is the difference, right? So it has to be a squared minus b squared. And that one factors into a plus b times a minus b. And you learned this in a previous chapter, that if you FOIL these over here, you will end up, the middle term will cancel, and you end up with a difference of squares. So you look at this and say, well, it's a difference of squares. So if it is, then something squared would give me 25x squared. What would that something be? Well, a 5x quantity squared, because you see a 5x squared is 5 squared x squared, because each one inside gets that exponent. So a would be 5x. What would b be if b squared is 36y squared? So b would be 6y, because if you square it, you get a 36y squared. So since this is a difference, meaning the minus sign, it will factor into a plus b and a minus b. So you just simply grab that a and the b, and the a and the b, and you check it by FOIL. I always put my plus first, because if there's repeated factorization of stuff on the left, I'm done with, and I continue on the right. Just because you change your order, that doesn't make it wrong. I just have certain ways that I like to be consistent. So let's look at this one. Also a difference of squares. So, but here's what I want you to remember. So many students factor this into 2x squared plus 8. 2x squared minus 8, because they immediately zoom in and say, oh, I have a difference of squares. True. The problem is 2x squared plus 8 still have a 2 in common, and 2x squared minus 8 still have a 2 in common. So I need for you to always, before you even think about, hey, is it a simple trinomial where I just open, close, or is it an over-the-top trinomial, or is it a binomial that is a difference of squares? I always want you to think, is there GCF before you ever touch it? Otherwise, you're going to forget some factors. So I'm going to say, is there a greatest common factor? Step one, if you go back up to the steps in the previous video. But step one is always pull the GCF. Is there something in common? Well, they both have a 4, don't they? They have nothing else in common. So don't try to pull stuff that isn't there. So some students pull a 4x. Well, there's no x in 64x. You can't do that. So 4, you pull it forward and you ask, open a parenthesis and say 4 times what is 4x to the 4th? X to the 4th. 4 times what is negative 64? 21. Oh, I'm having a moment. I can't even think right now. Kill that one. I'm going to cut that out. Can I cut that out? Yes. Okay. Start over. I can't even think. 16. Oh my gosh. Okay, start over. How embarrassing. Okay. Hopefully I'll find the right place. I'm going to change color. Okay, this is also a difference of squares, but first you need to look at, do they have something in common? So you should always ask. So you're going to say, oh, they have something in common. They both have a 4. Otherwise, you're going to factor this into 2x squared minus plus 8 and 2x squared minus 8. And then you'll notice that the 2x squared plus 8, they really still have a 2 in common, and you're going to miss that. So always pull the GCF. What do they have in common? A 4. 4 times what is 4x to the 4th? So some people here want to pull a 4x. There's no x in 64. You cannot pull an x out of that. So 4x to the 4th. X to the 4th. 4 times x to the 4th, 4x to the 4th, true. 4 times what is negative 64? If I'm not having a moment, it's a 16. 4 times negative 16 is negative 64. Then you say, am I done? Well, are you done? Can you do anything else? Then you look at this piece on the right and say, is there something I can do? Well, is it a difference? Yes. It's a binomial. Is it a difference? Yes. Is it something squared? That something is x squared. Is this something squared? That something would be 4. And then you say, oh, so I need to factor this into x squared plus 4 and x squared minus 4. And then you say, am I done? You always need to ask if you're done because you might not be done. And then some students take this first piece and they factor it. And I teach that in class, that if it's a sum of squares, you leave that thing alone. Do not mess with it. You cannot factor sum of squares. Sum of squares is prime. If you try it, you won't be able to. If you multiply it back through or FOIL it, whatever, you're not ever going to get x squared plus 4. So this is the reason I put my plus first. So we're going to bring that 4 down. That's in the past, but it needs to come down as part of your final answer. This last piece is a difference, you see? A difference of squares. And what would a be if a squared is x squared? A would simply be x. What would b be? It would be just a 2. So 2 squared is 4, true. X squared is x squared. So then you say, oh, it's a plus b and a minus b. And then this thing here is your final answer, and it's completely factored. So if you don't pull the GCF in the beginning, you have to do a lot of extra work to catch that, and students don't do that. So anyway, that's the binomials. What else do we have in here? This one I'm not going to cover because we've already done one similar. So this, I say factor, you say greatest common factor. There isn't one because there's a bunch of 2's in here and 3 and 2, but there's 3's in here, nothing in common between all 3. Then you say, what is it? It's a trinomial. Leading coefficient is not 1. Then you go over the top and you do the thing like, I'm not going to finish it, but you would do, my product is negative 72, my sum is 6, and then you have to find 2 things that make that happen. When you multiply them, it's negative 72. When you add them, combine them, it's a 6. So it's probably a 12 and a 6. You have to decide which one's negative. And then you split the middle into whatever you find here, these 2 pieces, right? And you repeat this one, like you don't change that and you don't change this one. You split the middle up, then you double bubble or factor by grouping if you want to call it that. Okay, so here's one. I say factor, you say greatest common factor. You need to always pull the GCF. Do not do 12 times negative 30, okay? Always pull the GCF because it makes the rest of it more manageable. So they all have a 2 at least. Do they have something else? The 30 consists of a 2 times 3 times 5. There's no 5 in here, no 5 in here, and there's no 3. Oh, there's a 3 in here. So they all have a 6. They don't just have a 2 in common, they also have a 6 in common. So you pull the GCF. You say 6 times what is 12y squared? 6 times what is 54? 6 times what, right? And then you see how these 3 have nothing else in common, but you're going to try to continue factoring. So you say, oh, what is this? Is this a trinomial? It's not a simple one where you simply open, close. You say, oh, I have to go over the top, and you're going to split the middle up. Product, negative 10, because 2 times negative 5 is negative 10. Sum is positive 9. Use the signs over here to make life easier. 10 minus 1. 10 times -1, -10, 10 minus 1, 9, true. Hopefully by now the factoring by grouping is becoming easier. This piece here is a part of my final answer. Do not forget it. What I usually do is I just bring it down into the final answer, or you can use, make it like this. That way you can work within brackets. I'm going to put the 10 near the 5. And might help you to just do a 1y here. So 2y squared minus 1y plus 10y is 9y, true. And then you have that -5. So you change nothing except you split the middle term up. And then you're going to double bubble this. And you have a y times 2y minus 1 plus 5 times 2y minus 1. Distribute, double check, you know, that's a common binomial factor. You pull it forward. And you put the leftovers in the second set and you bring that 6 down. Don't forget that 6. So the next one usually throws people for a loop a little bit because it's looks messy. It's not bad at all. And I'm going to put a, hang on a minute. I'm going to get rid of number 10 as far as this purpose of this video, because guess what? It looks pretty familiar. You've already done this. We practice in class a lot more. When I'm making videos, I'm not going to, I already showed you 2.5 of the factoring by grouping on the trinomials. Okay, so I say factor, you say greatest common factor. Is there one? And then you say, well, it looks really messy, but you see how they don't have a number in common, but maybe they all have some variables in common. I see an m cubed, an m squared, and an m. What's in all of them? There's an m inside all of them. And then I see an n cubed, n to the 4th, and n to the 5th. So there's an n cubed in all of them, you see? And then you open and say mn cubed times what is 27m cubed n cubed. I know that sounds funny, huh? We got to have a little fun. I know this is a stressful time, but we'll get through this. Mn cubed times what is -6m squared n to the 4th. So I need another m to make the m squared, and then I need another n to make the n to the 4th. Mn cubed times what is -mn to the 5th? -n squared. You see? And you double check it by distributing through. And then we're going to say, oh, am I done? Well, maybe, but maybe not. I'm going to do this one over the top, and I'm telling you, I'm not going to finish it because I've done too many of those already. If I'd known this was coming, I guess I should have paid attention. But I wouldn't have done all the others because this one time, but still practice for you. What would you have as a product? You know, and don't ever put variables over here in this shape. 27 times -1 is -27. And the product is the sum is -6. So you need two numbers that multiply 9 times 3, but you need a -6, so it has to be a -9 and a +3. So what do? You split the middle and you do just like in the last one. Don't forget this as part of your final answer, right? And you're going to end up with something like this after you do your factoring by grouping steps. And I think if this is it, hang on a minute. For now, yes. So I think that'll do for now. And then I'm going to have an exam 2 review video or several videos that should help you. But I want you to get warmed back up right now. It's been a long spring break and it's been an exceptionally weird one. So I would like for you to just focus on this and practice. This is critical to anything else you do in algebra. Thank you. Bye.